Hi, it's Mr. Crane. I feel like I need to create some video supports for you this week. So each day of this week, I'm going to help you out with your solar system assignment. If you look today, in just a few minutes, I'll unpublish this, or I will publish this, sorry, and it's going to say video supports for the solar system distance chart. So each day I'm going to do a different one. Tomorrow will be the diameter of the planets. The next day will be the football field scale diameter of the planets. And then finally one for scale calculations questions. So I'll make a support video for each day. So this one will be uploaded in just a little bit once I finish this video right now. If you're looking for the assignment, you need to have this assignment right here up and running. So where's that assignment? It's last Monday. I think it was March the 8th. If you click on that right there and you open it up, you're going to get this document right here. All right. So I've opened up a little chart here for us. So here's what we're going to do. We're trying to put all of the planets in the area of our football field, which is 100 meters. Okay, 100 meters. Now, that is the distance from the sun to Neptune. Okay, that one football field goal post to the other football field goal post is what we're trying to work with. Now, the distance from the sun to Neptune is 4,500,000,000. Oh boy, 500. Sorry, 500. Come on, circle. You can do it. 500. Good Lord. 1,500,000,000, which is this number I'm trying to work with right here. I don't know why that's not working. That's supposed to be a 0 right there. There we go. Nope, that's not working. There we go. All right. 4,500,000,000. So 100 meters of the football field. If we took this little square that is my screen right here, I want to put all the planets right there in this little area. So the sun's on one side over here, sun's over here, and Neptune's over here. So that distance is 100 meters to 4,500,000,000 meters. All right. Now, I'm going to erase this real quick. Now, what I need to do is set up an equality because we're trying to create a scale that we can put every planet out on that football field. So what I want to do is say just what I said. I want to say 100 meters. I'm going to try to write this bigger. 100 meters. Oops. Go back to a pen. 100 meters is equal to 4,500,000,000. Wonder if one of my other pens is better. Let's try this one. Yeah, it is. Maybe I spoke too soon. 4,500,000,000. 3 more zeros. 1, 2, 3. All right. So we're saying that's equal to that. All right. So we're saying that 100 million is equal to 4,500,000,000. So what I want to do is I want to create an equation that I can just plug in a number and get my desired output. So the answer I'm looking for in this graph right here, so here's our graph, there's the given distances, and what I'm trying to find is this number here. So this number here is going to be x. So this is x right here. All right. What I want to do is I'm going to make this bigger, and I'm going to say that, if I can move this, is equal to x as the actual that we're given. All right. actual. Good night. Actual. All right. So X is to the actual. So when I have this, you get your actuals from this graph right here. So here's our actuals. So they're using Mercury, 58 million. So let's go back to 58 million real quick. So this is the number we want, X. So if I cross multiply this, what I'm going to get is 100 times my actual, which I'm just going to represent that as a box, divided by 4,500,000,000. 4,500,000,000. We'll try this since this is a little bit better. All right. So I got that by saying 100 times the actual, 100 times my actual is equal to my 4,500,000,000, 4,500,000,000 times X. All right. Now I need X by itself. So if right now they're multiplying by each other. So if I want to get rid of them, I divide by the number I want to get rid of. So what I do to one side of the equation, I must do to the other side of my equation. 2, 3. All right, because of that, because I'm dividing that, what I do to one side of the equation, I do to the other side of the equation. That cancels. I'm left with X on this side. And what I'm left with on this side is 100 times my actual divided by 4,500,000,000. 2, 3. 1, 2, 3. All right. So there's my equation right here. It's the same as this one right here. See that? They're the same. So let's plug in an actual number. So it gave us Mercury. So I say 100 times Mercury, which was 58 million. I think that's right. We're going to double check that. 58 million. Double check that real quick. 58 million. I was right. So 58 million divided by 4,500,000,000. So if I type in my calculator for that, let's go back and we'll see. We'll get a calculator up here running. Get rid of that real quick. Get a calculator. It's thinking. Calculator. So I said 100. Still thinking. $100 times 58 million. 1, 2, 3, 4, 6. 2, 3. 1, 2, 3. Divided by 4,500,000,000. 2, 2, 3, 1, 2, 3. What number I get is 100 times 58 million divided by 4,500 million, 1.28. 1.28. Let's go back over to our thing here. Now 1.29. So if I round that up, so that's the answer for that. So let's go back to our little thing here. This equals 1.288. I think we're repeating 8, which will round that up to 1.29. So long story short, as you use this information, you get it to this point right here. You take 100 times whatever actual you're looking for divided by 4,500,000,000. You put your actual distances, these actual distances right here, and those are going to be your answers right there. All right. So you're going to find all of these numbers. Make sure you keep your decimal points right, and that should help you out. Good luck, and I'll see you on the next